Okay, these are the solutions for exam number 2. This is problem number 1. This is a limit as x is approaching infinity. So what you want to do is look at the exponents for the numerator and denominator, and the highest exponent in the denominator is 2. The highest exponent in the numerator is 2. So you're going to use the coefficients in order to figure out what the limit is. So the coefficient in the numerator is right there. There's a 1. And in the denominator, it's -4. And therefore, the answer was choice B. This is question number 2, and it's a limit problem, and the first thing we're going to try is substitution. So you'll have 0 times secant of 0. And we do not know what secant of 0 is, but secant is equal to 1 over cosine. So we have 0 times 1 over 1, which is just 0, and that was choice C. Okay, this is question number 3. You cannot substitute because you'll get 0 in the denominator, so you're going to multiply by the conjugate, which is 4 plus radical x. If you multiply out the numerator, you should get 16 minus x, and we're going to leave the denominator alone. 16 minus x and x minus 16, those cancel to -1, so you're left with this. And now you can substitute. Square root of 16 is 4, and 4 plus 4 is 8, and therefore the answer was -1/8. Okay, this is number 4. It's a limit problem, so the first thing we're going to try is substitution. So we're going to get sine of 3 times 0 over 3. That gives us sine of 0 over 3. Sine of 0 is 0 over 3, which is 0. And that was the answer. Just to clarify, this is not the rule, because this is sine of 3x over 3. It would be the rule if it was sine of 3x over 3x. So if it looked like this, then the rule is 3 over 3, but there's no x in the denominator. This is problem number 5. I cannot substitute, but I can simplify. X minus 4 over x minus 4 is 1. And the limit of a constant is the constant, so the answer is 1. Okay, this is problem number 6. You cannot substitute 0 in for x, so you'll get 0 in the denominator. So you're going to multiply by the conjugate. Okay, when you do that, in the numerator you're going to end up with cosine squared x minus 1, and then you're going to leave the denominator alone. Okay, the numerator should remind you of that trig identity, which says sine squared x plus cosine squared x equals 1. So you want it to be cosine squared x minus 1, so you're going to have to bring that 1 over, and then bring the sine over. So now you can go back and you can substitute cosine squared x minus 1 for negative sine squared x. And hopefully you're going to recognize that there's a rule in here, right there. So now we're going to break this up, and we have negative sine x and a sine x, and we'll take one x with it and put the cosine x with the other. Okay, so now this piece over here is the rule, and that will give you -1. And this piece over here we can substitute. So we're going to get sine of 0 over cosine of 0 plus 1. So we have -1 times sine of 0 is 0, cosine of 0 is 1. So we have 0 times -1, which is just 0, and that was the answer. Okay, number 7 was another limit with infinity, and so we're just going to look for the highest degrees in both the numerator and denominator. So we have a 2 in the numerator and a 3 in the denominator, and when the highest degree is in the denominator, that means that the function is getting smaller and smaller because the denominator is getting bigger and bigger, and it's approaching 0, which was the answer. Okay, this is number 8, which was probably the most challenging of all the problems. We cannot substitute 0 in there, so we are going to change the form a little bit. Secant is 1 over cosine, so that's my numerator, and here's my denominator. But we're going to need to represent 1 as a cosine with a denominator, so we're going to write this as 1 over cosine x, and then we're going to represent 1 as cosine x. Oops, sorry about that. It's cosine x over cosine x. The whole thing is still over x squared. So now we can combine those fractions in the numerator, and you get 1 minus cosine x all over cosine x, because the rule is keep the denominator, combine the numerators, and that is all over x squared. Okay, so remember this is a complex fraction, so we're going to change it to a division problem. So it's divided by x squared over 1. But we're now allowed to divide fractions, so we're going to flip that. And it becomes 1 over x squared. And then we're just going to multiply straight across. And you can see that you still cannot substitute, because if you put 0 in here for x squared, you're going to get 0. So I'm going to go to the next screen, recopy that last piece. This is where I stopped. And now I'm going to multiply by the conjugate. Okay, when I do that in my numerator, I'm going to get 1 minus cosine squared x, and I leave the denominator alone. Okay, and hopefully this rings some bells that you should be thinking of sine squared x plus cosine squared x equals 1. And we're looking for 1 minus cosine squared x. So we'll bring that cosine squared x to the other side. So now I know that I can replace 1 minus cosine squared x with sine squared x. So I'm going to rewrite that in my numerator, and the denominator stays the same. Okay, and now I'm going to start breaking this into pieces. So I have a sine x and a sine x in the top. I'll give each of them an x, and now I'm just left with 1 over the rest. Okay, and so now this piece here is the rule, so that's equal to 1. This is the rule, so that's equal to 1. And now I'm going to substitute 0 into this piece. So I'm going to get 1 over cosine of 0 times 1 plus cosine of 0. Okay, so 1 times 1 is just 1, and for my fraction I get 1 over cosine of 0 is 1, and I have 1 plus cosine of 0, which is 1. So I get 1 over 2 as my answer. Okay, so this is number 9, and this is a complex fraction, and I'm going to do this my way, not the Mr. Love way, because a lot of you made mistakes and forgot to multiply the denominators. So I'm going to do it the way that I know is not going to create mistakes. So I need 2 common denominators, and it's going to be x. So I'm going to have 5x here, and that's just 15 over x, and this denominator stays the same. So if I combine these, I get 5x minus 15 over x, and that's all over x minus 3. Make a division problem. I'm dividing by x minus 3 over 1. Then I'm going to change it to multiplication. And then I multiply straight across. I'm going to factor my numerator. And you can see that the x minus 3's are going to cancel, and I'm just left with 5 over x. And remember, this is the limit as x goes to 3, so I'm just going to substitute in 3. And 5 over 3 was the answer. Okay, here's number 10, and I'm happy to say that most of you got this right because we did this so many times in class. So we're going to change tan x to sine x over cosine x. We're going to make this into a division problem. So it's x over 1 divided by sine x over cosine x. Change it to multiplication and flip it. Multiply straight across. Hopefully you see that you have a little rule in here. So we're going to break it into 2. Okay, and now this is the rule, and that just gives me 1. And now I can substitute 0 in there. Cosine of 0 is just 1, so I get 1 times 1, which is just 1. Okay, and finally this was number 11. So the first question was the limit as x approaches 3. So 3 is right here. Oops, sorry about that. Okay, 3 is... where am I writing? Hang on. Okay, right here. That's where x is 3. So as I approach from the left side, my y value is negative 2, and as I approach from the right side, I have negative 2. So the limit as x approaches 3 was negative 2. That was the answer for number 1. Okay, go to number 2 now. Number 2 was the limit as x approaches 0. So as I approach 0 from the left side, I'm negative 1. As I approach from the right side, I'm negative 1, and therefore the answer was negative 1. Okay, number 3 was the limit as x approaches negative 3. So here's negative 3 right here. Okay, so as I approach negative 3 from the left side, my y value is 3. As I approach from the right side, my y value is 3, and therefore the answer is 3. Okay, number 4 was the limit as x approaches 1, but only from the right side, because it looked like this. The limit as x approaches 1 with the little plus means only from the right side. So as I approach from the right side, the y value is 2. So that was the answer for number 4. Okay, for number 5, this one was the limit as x approaches 1 from the left side. It has a little subtraction sign. So here's 1 right here. As I approach from the left side, my y value is negative 1. Okay, number 6 was the limit as x approaches 1. So as I approach, here's 1 right here. As I approach 1 from the left side, I'm negative 1. As I approach 1 from the right side, I'm positive 2, and therefore the limit does not exist. Okay, number 7 was the limit as x approaches negative 2 from the left side. So negative 2 is right here, and as I approach negative 2 from the left side, my y value is 0. That was number 7. Okay, number 8 was the limit as x approaches 4. So here's 4. As I approach from the left side, I'm at negative 4. The function ends there, so I don't even have to check from the right side, and the answer is negative 4. Okay, for number 9, it was the limit as x approaches 2. Here's 2. As I approach from the left side, in this direction, 0. As I approach from the right side, 0, and therefore the limit was 0. And finally, number 10 was the limit as x approaches -2 from the right side. So here's -2, and as I approach from the right side, I'm -1. That finishes the graph. And finally, this was the multiple choice question. So the secret here was to rewrite x over 2 as 1/2 x. And now you can see that this is the rule. This is sine ax over bx. Here's your a, here's your b. So the answer was just 1/2 over 1, which is just 1/2. And that completes the test.